Hi, the holidays are coming and it's time to work on some wearable electronics projects. In this video, I will tell you about SquareWear, which is a new open source microcontroller board that I designed for wearable electronics projects. The name SquareWear comes from its shape, which is a 1.6 inch by 1.6 inch square, so it's really small. Here is its size compared to a standard US quarter. It has large pinholes, which makes it easy to sew onto clothes and fabrics. It has a built-in USB connector, a general-purpose push button, LEDs, and a power switch. So here's a quick demo that shows when pressing the push button, it switches between several pre-programmed LED flashing or fading patterns. And this is the same demo program running on external LEDs, which are connected to the SquareWear board through conductive threads. Here is another demo that creates a waving LED pattern by adjusting the brightness of 6 independent LEDs. Again, these LEDs are sewed onto the tote bag with conductive threads. Because the SquareWear is small, it can easily fit behind another board to create a standalone LED badge like this one or this LED heart. I made SquareWear with a few different color choices and 2 battery options. The coin version runs on a 20mm onboard coin battery. It's suitable for starter projects and school workshops because this type of battery is low cost and is easy to find in local retail stores. The LiPo version runs on an external LiPo battery. This provides more power and can drive more LEDs, making them look really bright. This version also has a built-in LiPo charger, which is this little chip here, and it can charge the battery through the USB port. One feature that makes SquareWear really convenient to use is the multiple functions of its USB port. It is used for uploading a program and also for creating USB serial communication channel. This means you can program SquareWear and to send or receive serial data without any external serial cable. The USB port is also used for charging the external LiPo battery, or it can provide power directly to the board. SquareWear has 8 general I/O pins, which can be set as either digital input or output. Among them, 6 can be configured as analog input, so they are useful for interfacing with sensors. In addition, SquareWear has 4 output-only power sink pins, which are internally wired to these onboard MOSFETs. These 4 pins are capable of driving high current load up to 500 milliamps. The reason I designed these power sink pins is because very often you want to use a string of parallel connected LEDs to make a particular pattern, like this heart or this smiley face. Now, to switch so many LEDs and make them look reasonably bright, you have to be able to run a high amount of current through them. The normal microcontroller pins can only switch about 20 to 25 milliamps of current, which makes your LEDs look really dim. And with the power sink pins, you can switch a lot of current so your LEDs will look really bright. Another feature is that there are 8 pins which can be configured to run software PWM or pulse width modulation. So you can control LED brightness on up to 8 independent pins to make interesting patterns. Now, these software PWM pins have a 5-bit precision. There's also one hardware PWM pin which supports 10-bit precision. Some of these pins can also be configured to function as external interrupt pins, I2C and USART. Now I'm going to show you a few demos that you can find in the SquareWear software repository. I'm using these alligator cables to make quick connections for demonstration purpose. The first example is to use the analog input to control the brightness of the LEDs. So here I have a potentiometer set up as a voltage divider. And by tweaking the knob, you can see that the brightness of the LED changes accordingly. Of course, instead of controlling the LED brightness, I can also change the program to control the flashing frequency of the LEDs. With SquareWear's built-in USB serial functions, I can plug in a mini USB cable to SquareWear and then run a serial monitor on my computer to watch the analog voltages or sensor values. Similarly, I can also send serial data or command to the SquareWear board through the USB serial channel. The second example is pulse sensing. Here I have an infrared pulse sensor which consists of an infrared emitter and receiver placed next to each other. Now when I press my finger on the sensor, the blood circulation will produce subtle changes in the reflectivity of my skin, which in turn changes the output voltage on the sensor. You can use a serial monitor to watch the sensor readings, and in this case, I am running a processing program to visualize the sensor readings. Now these changes are picked up by SquareWear, and by using a simple pattern recognition algorithm, it can easily detect my pulses. And finally, when a pulse is detected, the program quickly flashes the LED to follow the pulse. This way the LED heart can blink in the same way as my heart beats. The last example is temperature sensing. Here I have a temperature sensor, 3 colored LEDs, blue, green, and red, and a SquareWear board, all sold onto a cap. The program reads the temperature sensor value and controls the brightness of each LED according to the temperature reading. When it's normal temperature, the green LED will be the brightest. As the temperature goes up, the red LED will light up and will become increasingly brighter. Here's the demo. I'm using a hair blower to warm it up. And similarly, as the temperature drops down, the blue LED will become increasingly brighter. And here I'm using some dust off to cool down the surface temperature of the temperature sensor. So this provides an interesting way to visualize the temperature. That's all with the demos. You can find more demo programs in this SquareWear software repository on GitHub. Now let me give you a quick overview of how to program the SquareWear. First, SquareWear is based on Microchip's 18F14K50 microcontroller, which is among the lowest cost microcontrollers that have built-in USB support. To enter the programming mode, simply press the onboard push button while sliding down the power switch. This will trigger the bootloader to enter programming mode. Because SquareWear uses Microchip's HID class bootloader, you do not need to install any driver. Next, launch the program loader and select a precompiled hex file. Then click on the Program button. And once this is done, click on the Reset button and your program should start running. SquareWear also has a software reset feature where if you press the onboard push button for more than 5 seconds, the program will trigger a reset and automatically enter the programming mode. And this feature can be disabled in software. Finally, SquareWear programs are written in Microchip's MPLab X, which is a fully featured and cross-platform programming IDE. While SquareWear is not based on the Arduino, it's designed to be as easy to use as the Arduino, and the software library abstracts away a lot of low-level programming details. If you are interested, take a look at the demo programs and the programming reference to find out more. That's all. Thanks for watching this video.